Assalamualaikum and hello everyone. Welcome back to chapter 5 vectors. In this video, we will continue with 5.1 part 3, perform addition, subtraction and scalar multiplication of vectors. Arithmetic operations of vectors. There are 3 operations will be involved: addition, subtraction and scalar multiplications. For addition and subtraction of vectors, add or subtract the corresponding components, such as I with I, J with J, and K with K. For scalar multiplication, we will multiply a scalar with a vector, such as lambda is the element of real number, will be multiplied for each component of the vectors. So now, let's apply what we have learned in previous slide by solving this example. Example 3a. Given 3 vectors in the direction component form, and you need to solve the following question by applying the arithmetic operation of vectors. One tip for you in solving vector problems, you can use column-metric form in the calculation, but at the end, you need to give the final answer in the direction component form. So let's try part A. Given 3a plus 1 over 3b minus c, so you have to multiply the 3 with vector A and 1 over 3 with vector B. And then we combine with minus vector C. So we bring in 3 and 1 over 3 into the column matrix form of vector A and B. At the end, we're going to have 8, negative 7 over 3, 11 over 3. And we change into the direction component form. We're going to have 8i minus 7 over 3j plus 11 over 3k. Okay, part B. So we have to find the magnitude a minus 1 over 3b. So first of all, we have to find the a minus 1 over 3b. And then we simplify, we're gonna have the answer, which is 10 over 3, 1 over 3, negative 7 over 6. Or in the direction component, we have it 10 over 3i plus 1 over 3j minus 7 over 6k. Thus, to find the magnitude, we can have a square root of each component squared and then we simplify inside the square root. We're gonna have square root of 151 over 12, and then the final one we're gonna have square root of 453 over 6. Now, we move to the next one, resultant of 2 vectors. In vector geometry, resultant vector is defined as the sum of 2 vectors which has its magnitude and direction. For any vectors OP and OS, in order to find PS, it will start with PO plus OS. But since the information given, which is OP instead of PO, so you have to change your vector PO to be negative OP. So that's why we have negative OP plus OS here. So the same pattern if we want to find the SP. So we'll start with the letter SO plus OP. So as you can see, we have the vector OS instead of SO. It's going to be negative OS plus OP. So the easiest way in finding the resultant of two vectors is by subtraction of position vector of vector at the back with the position vector of the vector at the front. So let's say if you want to find the vector AC, it's going to be OC minus OA. Easy peasy. Now, let's try example 3b. Given 2 points A and B, part A, express the position vectors of the points in terms of unit vectors I, J and K. So, for the position vector A, it will be OA, and the position vector of B, it will be OB. So OA equal with 2I minus 3J plus 7K. And OB equal with negative 2I plus 4J plus 3K. So move to part B. Find the vector AB and its magnitude. Okay, to find the vector AB, it will be involved with the resultant of two vectors. As we know from the previous slide, resultant of two vectors is defined by position vector of vector at the back minus position vector of the vector at the front. So in order to find AB, it's going to be OB minus OA. So we change the direction component from part A to be column matrix form. We can have negative 2, 4, 3 minus 2, negative 3, 7. So simplified, we're going to have negative 4, 7, negative 4. So at the end, you have to change back in terms of I, J and K. It's going to be negative 4I plus 7J minus 4K. Thus, you have to find the magnitude of AB, which is, we will have it the square root of negative 4 square plus 7 square plus negative 4 square. So total up everything inside of the square root, we can have square root of 81. It will be equal to 9. Part C. Find a vector H has 4 units long in the direction of AB. So by notation, we can have H equal with 4AB hat. So what is AB hat? AB hat is equal with vector AB divided by its magnitude. So from the answer in the part B, we're going to have negative 4I plus 7J minus 4K over 9. So we substitute the whole thing into the equation H equal to 4AB hat. So you can bring in the 4 into the bracket. We're going to have negative 16I plus 28J minus 16K over 9. So that's it for now. I will see you again in the next video. Take care and bye bye.